Number 9, it says to find the 10th term of the sequence given a sub 1 is a 1/16 and r is 2. So since I have an r value here, it tells me right away that this is geometric, which means I'm using one of these formulas off to the side over here. And since I'm looking for a term, I'm using this formula. So that's going to be my a sub n equals a sub 1 times r to the n minus 1. And now I'm just going to plug each of these things in. So this is time I'm looking for a sub 10. A sub 1 is a 1/16 times r, which is a 2, raised to the n minus 1, n being the 10. And now just following order of operations, I have to do the exponent first. So that's going to be to the 9th, and then multiply it by the 1/16. And just when you do this, make sure you follow order of operations and you do to the 9th power first. That gives you the 512. And then multiply that by the 1/16, and you'll end up finding out that we're at a 32. Okay, so the 10th term is 32, and that's it. Number 10, it says to find the sum to the 12th term. So again, we look at the pattern that's happening here, and if I look, I'm multiplying by 3 each time, and since I'm multiplying by 3, it means that this is geometric, which means my r value is 3. And so now I look at the other information that's given here. I'm given a sub 1 is a 1/9. I'm given my r value, and there's not much more I need since I'm looking for the sum. I'm using this last formula over here. So it's s sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. And I just have to plug this in. I'm looking for this to the 12th term. I know a sub 1 is the 1/9. I know r is the 3. Again, I'm looking for the 12th term, all over 1 minus 3. Now I just have to plug this in very carefully. When you do this, make sure you follow order of operations. We do the 3 to the 12th power first. Down here I get a -2. When I subtract this, that's going to give me a negative. Again, I have to multiply that by the 1/9 and then divide by the 2. And when I do that, I find out that I have a 29524 and 4/9. Okay. For number 11, it says to find the sum, and it's giving me summation notation or sigma notation. It's telling me my starting value is 1, my ending value is 7, so I plug a 1 in first, and that gives me a 3. And then I plug a 2 in, that gives me a 5. I plug a 3 in, I plug a 4 in, I plug a 5 in, I plug a 6 in, and I plug a 7 in. Okay, and that's where I stopped. It's telling me to go to 7, so now I've plugged in all of my terms, and now I just have to add these together. Okay, so here that gives me an 8 plus 7 is 15, 30, 39, 50, 63. Okay. For the next one, it says to write this decimal as a fraction. Remember, when we have a repeating decimal and all the values are being repeated, I just put the 3 repeated values over however many 9s I need. In this case, 3 repeated values goes over 3 9s. Okay, if it was 2 repeated values, it would go over 2 9s. And I just simplify this thing as far as I can. When I look at the 315, it looks like that's going to be able to reduce. They're each divisible by 9 for sure. I don't know if they can reduce any further than that. Let's see what I get. When I divide them each by 9, I get 35 over 111. And I think that's it. I don't think that's going to reduce any further. Okay. Number 13, it says a standard number cube is rolled. What is the probability of rolling a number less than or equal to 5? So rolling a number less than or equal to 5, there's 5 available options out of 6 total options. And the last thing I do is reduce, which this one doesn't reduce. So it's just a 5/6. Okay. Number 14 says a standard number cube is once again rolled. What are the odds of rolling a multiple of 3? Well, there's 2 of those. I could roll a 3 or a 6. Those are multiples. So there's 2 out of 6 total. But remember, odds isn't favorable. It's not how many ways this can happen versus the total. It's how many ways this can happen versus how many ways it couldn't happen. Okay, so if I can roll a 3 and a 6 to get a multiple of 3, I could get a 1, a 2, a 4, or a 5. There's 4 options where I don't get a multiple of 3. So the odds are 2 to 4, which reduce to 1 to 2. Okay, again, probability is favorable over total. Odds is favorable versus unfavorable. In number 15, I just want to simplify this. Remember, factorials are taking like a 10 factorial is 10 times 9 times 8 times 7 all the way down to 1. So the 10 factorial and the 8 factorial I can reduce. Everything from 8 on down cancels out, which means I'm left with a 10 times 9. All over 2 factorial, which is 2 times 1. So that's 90 over 2, which is 45. Okay? And number 16, 0 factorial is one of those special cases. Remember, 0 factorial is 1. Again, think of it in terms of arrangements. Arranging nothing, there's still one way you can do it. Number 17, we're doing the combination. So remember, the combination is, it's the combination of n choose r, which is going to be n factorial over n minus r factorial. So that's going to be a 6 factorial over 6 minus 4 factorial. So that's 6 factorial over a 2 factorial, 4 factorial. Once again, I can reduce the 6 factorial and the 4 factorial. That's a 6 times 5 over a 2 factorial. So that's 30 over 2, which is 15. Okay? And number 18, this is a permutation. So the permutation of n choose r, remember, is n factorial over n minus r factorial. And so now this is going to be 5 factorial over 5 minus 2 factorial. So that's 5 factorial over 3 factorial. Again, I can reduce this. Those cancel out to a 5 times 4 with nothing left in my denominator, so a 1 left in my denominator, which is just going to equal a 20. Okay? And the other way to do that, remember, we do have our combination and permutation buttons on our calculator. Number 19, 2 marbles are pulled one at a time. Probability of purple, then yellow, with replacement. And that's very important. With replacement, it means we pull the purple one out, put it back. So purple, there are 8 purple marbles out of, looks like 28 total. So it's 8 out of 28. So I pull out a purple marble, I put it back. Now the probability of yellow is 16, and there's still 28 marbles out of 28. The word then implies the word and, which means I'm going to multiply. And of course, I can reduce some things. Here, the 8 and the 28 reduced to a 2 and a 7. The 16 and the 28 reduced to a 4 and a 7 by dividing each of those by 4. And it looks like that's all that's going to cancel out for now, so I multiply straight across. That's an 8 over 49. And that's it. That's my probability. In number 20, 2 marbles are once again being pulled, but this time it's without replacement, and I want 2 pink. So for the first pink marble, it's 4 out of 28 because there are 4 pink marbles out of 28 total. So now I pretend for a moment that I've pulled that pink one out. Now there's only 3 pink marbles left, and there's only 27 marbles left to choose from. Again, the word and is implied here, so I'm going to multiply, but I still have to reduce. This reduces to a 1 over 7. Over here, this reduces to a 1 over 9. And now I multiply straight across. That's a 1 over 63. That's it. Number 21, 1 marble is pulled, and we want the probability of pink or purple. So or this time is a little bit different, but for the pink, there are 4 pink marbles out of 28 total. For the purple, there are 8 purple marbles out of 28 total. The word or here tells me that I need to add. And since these are mutually exclusive, there's no marbles that are both pink and purple at the same time. That's all I have to do. And I'm just going to add these straight across. That gives me a 12 over 28. And notice I don't reduce this ahead of time just because I want to keep my common denominators. Now I'll reduce. This reduces to a 3 over 7. And that's it. And this one says that there are 8 butterscotch and 5 vanilla cups of pudding. 5 are selected at random. What's the probability of getting 3 butterscotch and 2 vanilla? So for this one, this is a little bit more complicated. I am choosing a couple different things. I'm choosing the butterscotch, and then I'm also choosing the vanilla. And so what I have to do is I have to do a combination for each of these. For the butterscotch, there are 8 butterscotch, and I want to pick 3 of them. For the vanilla, there are, once again, let's see, there are 5 vanilla, and I'm choosing 2 of them. And this is an and. It says so right here. I want this to happen and this to happen, so I'm going to multiply these 2 things. So I have to do each of these combinations. The first one, the combination of 8 choose 3, gives me a 56. The combination of 5 choose 2 gives me a 10. When I multiply, that's a 560. And then from here, I have to do a combination for the total as well. So I'm going to do my total. There are 13 total cups of pudding, and I'm choosing a total of 5 of them, so I have to do the combination of 13 choose 5. And that gives me 1,287. Okay, so now I have how many ways this thing can happen with the 560. I have how many ways total options there are. So now for my probability, I just do the 560 over the 1,287. And I just have to reduce this. And looks like that's not going to reduce. I'm going to leave it exactly the way it is. Okay? So that one stays just as it is. If I take a look at the next one, it says there are 1,600 students enrolled. 600 take algebra, 500 are taking German, and 300 are taking both. If one student is selected at random, what's the probability of algebra or German? So again, or. So the probability that they're taking algebra, there's 600 of those students out of a total of 1,600. The probability that they're taking German is 500 out of the 1,600. This is an or, so I need to add. But unlike the previous example where it was an or, these are not mutually exclusive. These are inclusive. There's overlap here. There's 300 students that are counted in that 600 and in that 500. I've counted them twice. I need to subtract the overlap, the probability that they're in each of those. So I subtract the 300. Okay. So now when I add these up and I subtract the 300, it looks like I get 800 over the 1,600. And that reduces to 1/2. Okay, and that's it.